Contacts, wedge. See audio. Mic on, camera. Mic on. Yes. Hello, hello. Looks like I got audio. I guess I do. Hello, hello. Let's see, built-in microphone. Built-in microphone, that's on. Okay. I guess I got audio. Let's see if we get Facebook to link up. A little bit of problems here. Crazy. Let's see. Nothing seems to want to work. Showing I have audio. You guys can hear me, let me know when you come in here. If you can text, I don't know if you can do that or not. Nothing seeming to want to work today. I'm trying. There. Looks like I have audio. Good news.
Yeah. Yeah. Yeah.
That took a lot. Just get that running. Holy moly. Alright, we finally got this thing running. Cool. What's going on? It's Friday, man. Welcome to the weekend. Ricky Bobby's in the house. What's going on, Ricky Bobby? Oh, Ricky Bobby up in here.
Strong 1, 2, 3 style, that's get clean. Get down, watch the mud ducks fold. South Jersey Amps, yeah, the story gets told. Bleed over burning.
All right, we'll get this thing started here. Mike Smith, thank you very much. You're making some killer songs for me, man. Ain't did anything new lately, but that's all good. We got plenty control, and plenty of videos and songs. All right, let's try to explain a few things here. What's going on? It is Friday. Welcome to the weekend, everybody. And just Molly and me down here in the shop saying, "What's up, Molly?" Say hi, everybody. Yes, taking naps. That's what you do. You and Seal and your bones. All right. So, as I said in the comments, if you guys took the time to read them, that this is a PsychoZip 5-pill driver driving 12 2879Cs. Now, yeah, a 5-pill is a big driver for a 12 because you really don't need that much. You only need a certain amount of drive to get these things up to full power depending on the voltages you're at. And if you go over that drive, you're just going to create a lot of heat and a lot of frustration. So you should probably take and consider to doing a little bit of math with a calculator, and it's very, very simple. I think my good calculator died on me. Let me take a look. My bigger one. Yeah, it's 10.7. Solar battery died. So we'll get the other little calculator over here. Let's just kind of go over this now. You guys, this is going to be a long video. I'll warn you now. This is going to be one for you can understand all the way down to the insides of these transistors. This is a 2879C right here, and it is what it is. Don't look very good. It's been laying around here. It's been blown up once. But if you look inside this transistor, each one of these little square things is a chip. Each one of these little chips can handle about 5 watts maximum. See, there's 6 of them in there. I had a pointer, I lost it. All right, so let's see if I can get, where am I at? All right, so each little square, there's 6 chips in here. 1, 2, 3, 1, 2, 3. And each one of these are basically 5 watts of drive maximum. So that makes this in a whole of a 30 watt drive. Now, HG may be rating that at peak numbers. You know, everybody likes that peaker tweaker thing. But as you get into these transistors, as we all have a few years under our belts with them, and what you can and can't do with them. Some builders cannot build with 2879Cs. God forbid, I don't understand why. If you're a builder, you should understand how to build all or with almost all of the transistors of the same type of voltage. So, keeping forward and focused, we're talking about drive. And inside of these transistors, I have 6 chips. And each one's good for basically 5 watts max. Now that same thing falls under the same category as the standard 2879. That's what this one is here. You see there's only 4 chips in here. And then a 454 only has 3. And then 2290 has 2 and configurations and such. So as you look at these transistors internally, there's not a lot we can do about how they're designed or how they're built. I've been working with HG for quite some time now. I've been working on some other stuff with them, and it's a slow, drawn-out process, and it does take a long time to get changes done. Remember, they're in a different country, and I'm here in the United States, and there's probably other people trying to fill that man's mind with good or bad ideas as well as I am. So, with that said, this is what we have inside of these 2 amplifiers. The 2879 has 4 chips. That's in the Psycho Zip. And the MooZilla or the MoWatts would have 6 chips in them. And that is a better transistor than this. Why? Because you got a little bit more headroom. And in fact, you would look at 5 watts of input drive would be maximum drive. So you would consider each one of these chips producing right around 25 watts RMS. All right? Because we see 100 watts out of them. They call it peak. But we can basically get 100 watts out of a transistor somewhere right in there. It all falls down to how good you can tune a circuit. That sounds like a game show for sure. How good can you tune a circuit? So if you're looking at transistors, these are what you're seeing. 2879 is here. 2879C is over here. And that's what they look like on the inside. Now, keep in mind, you got 4 chips. 20 watts is maximum drive. And I'm leaving you some headroom there. All right, so I'm not saying go out there and run 20 watts and it's going to blow up. No, that's giving you all just a little bit of leeway. Let's say a little headroom. And so with the numbers I'm giving you guys and the smart numbers to run this stuff at. So with all that said about transistors, we're going to get over here to this power supply. So this power supply is pretty fancy. Got a lot of stuff going on with it. And this is the color pattern that the guy wanted. And it was purple and orange. And that's what we went with. So, you see there's a lot of switches on here. And I got a knob and another little switch. And I also have a screwdriver. Now, this is something that I'm getting ready to talk about and show you about these little meters here that we're using for what we're not supposed to be using them for, but they're working out fine. But I found a little glitch in my system, and there's no way yet I figured out a solution for it. So there's only think one other guy that has these switching power supplies I built with a rider power supply, and that's his variable power, and you're sharing this meter up here. So we're going to get into that little glitch and what you have to do to get around it. But in the meantime, this is the new cabinet I designed a few years back. I based it off this one up here, and it gives me a lot of room inside, and it gets a little tight back here because I can't really get the camera on it. But I didn't label it yet, but there's two positive studs. You see one's down there for the driver, that's got the black ring. And then the big isolated 1/2-inch bolt, that's for the 12 pill. And then you share a 1/2-inch bolt ground that's hooked up to the 500 amp shunt. And then also there's a radio jack here, and we'll talk about the radio, how it will function, and how if you were to read it without a radio on, and as you turn it on, how does the voltage step down. So here's how we got this one set up. The first switch turns on the small power supply that will run the driver. Now I'll turn that on, I flip this switch down, and that would be because it's only, the only energy that it would have inside this thing. So if I hit the switch up, it's going to go out because the other 3 power supplies, or one of the 3, are not on. So as of right now, we are turning this on, and this is where my voltage is set at. I can back it all the way down to, we can go down to 12.2 volts, I guess. And yeah, you can really turn this up as a 10-turn pot. I'm spinning. I need more than 10 turns, but either way, that's maxed out. It stops at 16.35 volts. Don't really need all that for a driver if you really want to try to break something. So this is part of the system where I like to say this is very much controlled. So I like to take and control my equipment with voltage, and try not to take and turn the potentiometers down too much on the amplifiers, just because they just kind of want to act wherever they want to act. So going back to this, now this is a current meter. This shows that it's what the shunt would have in here, which normally this meter was designed for a 100 amp or a 50 amp shunt system. And I thought about this many years ago. It's been probably at least 8 or 10 years or so, about probably 8. I took and was doing dual. I had just an amp meter and just a voltmeter, and his double holes and a bunch of other stuff, and you had to add some power supplies. So I made this a little bit easier. Deuces in the mini grass. What's up? All right, so going back to this, it says current right here. Now if I were to turn this amp on, which I will, it's going to show me a current draw of, it's like 1 point whatever amperage. All right, the decimal don't read. You just kind of just eliminate that because we go past it. But here's what we have to check. Hold this button down. It says set, and it'll go clear, and it'll say current. You see it says 100? You need it in 50 mode, because this is auto. I don't know if they made a change or if this meter is just doing what it wants to do. I'm not sure. I would have to go back and do some more testing. But what happens is if I power this down, you've seen I just ran that. Let me just shut this driver off. It's not necessary to be on. But if I power this unit down, you're going to see that when I power it back up, this is going to go back to an auto or a natural reset. Got a little drain on it. All right. So it'll go to a normal reset mode. So if I turn it back on, it's going to reset, but it's going to go back to a default setting of 100 amp. I don't know why this one's doing this, but it's doing it. And I haven't figured it out. I'd like to figure it out before the guy gets it, because I sure hate to tell a guy every time he wants to read his amperage correctly, you got to hold that down. And unfortunately, you've seen it went right back to 100. So it kind of sucks. I apologize for it. I don't have a solution for it, but as soon as I do, it's easy enough to fix. Push this meter out, change the wires into a new meter, and plug it back in. It's easy enough. But hopefully I'll be able to come up with a solution for that. So inconvenience, I don't know. I didn't notice this with the last system I made. So moving forward and moving on. So that is that power supply. So this one here, as you see, we already rolled the voltage up and down on it, and this is independent from these other 3. Now I turn these on here. Now the fans kick in. You'll hear a fan in the back. No need for this. They have its own fan for big current, you know, big cabinet. If you're just talking on just a driver, it's got its own fan, and there's a fan in every one of the power supplies, a couple of them actually, and they'll kick on if they need any air. But with that said, I do have a cycle fan hooked up, 120 millimeter in the back, and they're tied in with the 300 amp service here. So if I turn all these on, as you can see, my voltage never changed because I have to hit the switch upward, and now I can share this voltmeter with the meter that I have in here already. Put a small battery in there, a whole memory. No, thank you. No, I can't do that. It's supposed to be self-contained. I think the unit might just be messed up, Scott, but I got another one. I ordered some more, but I have another one here, and I might try it just to see if she wants to act right. But going on, I hit the switch upward. Now I'm going to read the voltage of the 300 amp power supply, and that's where it's setting at, and then my amperage will follow as well. And just for kicks, I'm just going to hold this and see if it stayed the same. And we'll go on over to its little setting thing, and it'll say that, yep, I'm at 50. Cool. All right, so moving on, moving forward. Let's take a look at this stuff. So as I took and did these builds, I controlled this driver. Now here's a little Psycho Zip driver. A lot of people are like, man, why is it such a difference in price between the South Jersey boxes and the Psycho Zip boxes? This is a fully custom line, and it's freaking gorgeous. I do spend a lot of time on the South Jersey line, and they are gorgeous, but this is badass gorgeous. So this is what you get, custom stickers. However I can take and make it look cool with the colors that you pick is the way I go with it. So this is what I have in this one. It has one 2879 driving, 4 2879s. And as I said, that this is a controlled unit. And the unit of control falls into what I have on the potentiometer, which I have a 47 ohm resistor there. So that means it's going to slow down quite a bit. If I put a 1.8 ohm resistor on it, it would probably take off and do all kinds of power. We don't need that much power for a 12 pill. So I wanted to take and design the system where he'll be able to fully leave this clock wide open without having to back it down whatsoever. And then he will take and be able to take and control his voltage over here on the driver that will control the overall outcome of how this is going to perform. So, and if that's not good enough, you still got pullback right here. So, with all of that said, you have these things for control, and that's why I try to design them. I mean, the little amperage thing, that's a little glitch, and I'll figure that thing out. It kind of really bothers me that it popped up, and I never noticed it before. Maybe I didn't do that test, I don't know. But there you go, there's a little zippy 5 transistor unit. Now we'll get into the MooZilla 12 transistor unit. Pop the skin on this one. We'll just take a peek. Boy, she's pretty. Come on, really nice. So 12 2879Cs inside here. I have 4 6-gauge wires feeding the system. Still has a remote system in here, even though it is a base unit. So I have 4 filtered inside electronically and outside for the airflow. Filtered fan kit in here. Each one of these fans is 108 CFM. Put out a lot of air. You should be able to get ample talk time out of this unit, out of this whole entire system. It's a good looking system. It runs really nice. You do the numbers, we'll start crunching those here. We're going to start running this stuff. So I'm going to be on the dummy load today, I should say. And let's just take a look. I'm just going to run that 300 hertz tone here, or I can continue to talk. So let's just take and look at the driver. Let's see what we have out of this driver. Let's run her all the way back. And before I do that, I want to show you guys one more thing here. Okay, also on the back of this power supply, there is a jack for, let's say, a Cobra 29, less than a 6 amp radio or so. This is a Cobra 25. I just have it plugged in. I'm not going to transmit on it, but I just want to show you what the voltage is going on. So you can see this unit is off. Okay, I shut it off. Now, let's turn on my voltage on this one, and it's showing me I'm at 15.47 on that radio jack. You cannot freak out about that, because as soon as you turn this radio on, now I'm going to put my hand on the knob, as soon as you turn it on, it's going to drop. There you go. So now when you transmit, it'll dip down a little bit more, so you will not go below 14.2 volts. And there's, I mean, you can monitor on your own voltmeter if you like, but I've been making these internal radio hookup jacks off the power supply for many years, and I do it on the fixed side of the voltage, which is, oh, what is the voltage over there? It's 15.75 or 6, somewhere right in the 7.6. So that is the voltage where it's coming off of it, but the radio's on right now. If I cut the radio off, yeah, it's a little bit lower than what's on the face of that thing. But as soon as you put a little load on there, she drops right where it needs to be. So radio jack and all that stuff is very friendly. You won't have any problems with that whatsoever. So let me disconnect this just so I won't bump anything and cause a small fire. A little smoky, puffy test. All right, let me light up a few things, turn things on. Okay, now let's take a look at what we can do with this driver. All right, now real quick, we're going to go over the slugs. We're going to look at a 25 watt slug going back to my driver and a 1,000 watt slug feeding into the RMS of the system. Now, driver's wide open. Turn our voltage all the way down. Let's see where we're at. All right, we're at 12.1 volt, almost 12.2 volts. I'll throw a little carrier there, show me a little amperage there. About 43 amps is all it's showing there. About 43 amps over here on the clamp. And with that said, we're looking at, I'm only producing, that's 1,000 watt slug. I'm producing 150 watts or so. Don't show me 350. Yeah, that's right, 1,000. So that one over there shows me 350. Let's see what it says over there. 225. All right, so 225 watts RMS is what it's showing me out at. Maybe a little bit more on the analog. Okay, let's see what the peak are doing. All right, so 500 watts. That's back all the way down on the voltage. Now if I turn this all the way down here, now what do we have? Looks like about 25 amps there. 25 amps there, okay. And let's see my drive now. It's 1,000 watt slug, each line is 20 watts. So we're showing about 120 watts RMS. About 100 there, all right, cool. Let's see what this one tells me. This says 200. Not the right reading for this. Microphone's twisted. All right, finger twigger. Lost a little bit. Woohoo. Okay, so that's quite a bit of control. Now, if I were to leave that all the way down, say, hey, I want to pick this amplifier up. I'm going to go over here and I'm going to twist the knob. You'll hear the fans increase. Let's just go up here to wherever it stops. Here, let's do this. That's where it stops. 16 volts. Cool. Okay. That's the potentiometer's all the way down, all the way up. So about 31 amps, yep. So 16 volts, potentiometer on the amplifier all the way down. Turn this up a little bit. There you go. Now I'm barely making 200 watts, but my peak 700. Get some of that. Why did my peak increase so much? Because I increased the voltage a lot. Went from 12 volts to 16 volts, but now what's going to happen when I run this wide open? Let's see where my carrier is at. Okay, I'm safe. All right, turn this on. Now, this is wide open. This is wide open. Let's see what we got. 55 amps. 55 amps. 1,000 watt slug. All right. 420 watts RMS. Again, that amplifier is controlled. What happens here with our forward power? It's peak, RMS. Let's see what the reflect shows. 5 there, 1050 there, 900. Okay. So, I'll take the 900 or 1,000, somewhere right in there. It's a reference. But, any way you cut it, this is the part of what I call the system control, because you can control the knob here, and then you can control the knob here. Wherever you decide to get it there, that's cool. If you don't have a radio that will get this thing excited enough to get 300 watts out of it, because that's what you're going to need, we'll get to that calculation here in a minute, you just take in run the radio you have, and you find the watts that you need between these two knobs, between the driver and this power supply. So you get it somewhere right in here, and you're wide open, we should make right around 300 watts of power. All right, so now we're checking out about 46 amps, and we're making 300 watts of power. All right, and our peak is right around 600 there. Let's see what this one is. 750 there, that's all fine. So, may as well just leave it up there because I'm getting ready to go to the next mode. Molly! What's up, Molly? How are you? What's happening? You gonna sit? How's things? You doing good today? Yes, you are. How are you? Yes, yes, yes. Here, you want a peanut? Here, get a peanut. Oh, here, here you go. There you go. All right, we'll get to you in a bit too. There you go. Nice to see you, Molly. Yeah, this is the MooZilla up here. It's all about you. All right, so moving on, we won't lose track of time. I have this driver now producing 300 watts RMS, and that's a really nice number. Now, going back to that nice number we talked about, that 300. So you take that same 300 watts and you divide it 12 times. That's 25 watts of transistor I'm going to feed into this box. It'll sit there and take it, no problem. You have headroom. Remember, 5 watts of transistor is full max. So, I take and turn all this mess on. Take and look at this one over here now. Okay, let me throw a carrier. That's a good carrier. We'll throw a tone. All right. So here we go. We're going to light them up, light them up. I'm going to first show you what's happening down here on the digital screen. And things will just load. So my voice will make things do things differently too. So here we go. This is what we have right here. It's showing about 15.3 volts. It fluctuates, as you can see. But we're drawing 239 amps. And it's showing me 247 over there on the clamp. And that's both of them together. Okay? Both units together. 245, 246, somewhere right in there. This is a reference, guys. This isn't the Holy Grail. This is science grade voltmeters and amp meter test equipment. This is something that's kind of like a dosimeter. Gives you an idea. You're in the ballpark, and this is where you're going to be at. So that's why I always like to back up my system with clamps and check things. But there's no adjustments I can make to these meters to make them more accurate than they actually are. So, kind of is what it is under that 10% law. So, here we go. Let's take a look at what's going to happen up in here now. All right, input drive level. This is my working drive. This is under a load, driving into the 12, and it has things going on with it. So, let's see what we got. All right, we're hanging out right there at a 300 watt mark right there. Input reflection, this is a 25 watt slug. Each line is a half of a watt. And we're looking at right under 2.5 watts as far as that goes. Now, here's a 2500 watt scale. Each line is 50 watts. And let's see what we're going to produce. All right, we're producing right about 1650, 1700. Let's see what the 5000 watt scale says. Each line is 50 watts. Center scale. That looks like a good 1700 there. And let's see what the RMS is down here on the 5 kilowatts. Show me 1700. Let's see what a 2500 says. Show me 18 and a quarter. Then go back to reflect because I'm hitting the peak meter. I will over exceed the 2500. We're at 3500 watts peak or tweaker time. All right, that's with a tone. So if I take the tone off, and the next question is, where do I set my dead key? Well, I would normally say just scream in the microphone and find out where it lands and cut that in half. Good rule of thumb, especially with a bird. You cannot do that with peak, but you can do it with RMS or average power. So here you go, there's a carrier. And I'm going to talk. Audio, 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 1, 2, audio, audio, 1, 2, audio. I really don't know how good this microphone is, so I'm going to turn it up because I got that machine plugged into it. I know when I key up, I hear it buzzing through here. That may kill the element, I'm not sure. Audio, 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 audio. I guess it's working all right for a stock mic. All right, so enough to hooting and hollering. I got that bad boy right there. I just poke the button. This there, just crawl right on up there. Get up and get it. Alright, so everything is stable, everything's very, very happy. Yes, I am in a dummy load, but if you get off into, I'm on an antenna, now this is the part that I'm going to talk about that's really, really important. It's called phase angles. The phase angle of coax, meaning from your radio down to your driver, from your driver to your next box, and then off to your watt meters and antenna, or dummy load. Alright? Smart guy is going to stub tune his coax and get it on frequency, or get it within at least the zip code of the ballpark of the frequency that you want to talk on. You can do the calculations in math and say, all right, I got 492, and then I'm going to take and times that by 0.66 and then divide it by frequency 27.025 and equals, it says, hey man, go cut your coax at 12 feet. That's where that number came from. That's the slang for what? A half a wavelength. Now you say, oh, well, I need a 6-footer. Well, that's the slang for a quarter of a wavelength, because if you took and divide this by 2, there's your 6-foot calculation. Okay? So, would you need a 3? What happens there? Divide it again. There's your 3. That's your calculation for it. You see all these odd numbers down here? Those are the frequencies you guys aren't catching on your calculator. So, and when your tape measure, when you measure it out. So, if you were to cut your coax at, let's just say hypothetically at 12 feet, and now you hook it up to an antenna analyzer, which I have a video on YouTube. You can go down that rabbit hole and watch it. But you hook it up and you sub-tune it. That piece that you did with the calculator is fairly close, but you might be 80 to 100 channels away from your target channel or frequency that you talk on with your coaxial jumper. Okay, so it's no different than if you were to take and say, oh, I got a new Mako 7-element beam. You just push all the elements together and, oh, that looks good, and put it up. Don't check your standing wave and go fire up. You don't know where you're at. So, kind of the same thing with the coax. If you're going to spend the time to tune your antenna to the channel that you're going to talk on to get a very good standing wave, I highly suggest you should follow that same thing and do your coax for your radio to your driver, from your driver to your next piece. And that's why stub tuners only have quarter wavelengths and half a wavelength measurements for them. Now, the 3, the 9, the 18 numbers, they're not in that equation at all. So you have to keep that in mind. Now, will you need a 3-foot? I don't know. Hard to say. You own your antenna. You have your own electrical service in your house. You plug this stuff in. I'm going to make a suggestion. I'm going to say, listen, you're going to run a half a wavelength from your radio down to the driver. Half a wavelength. I don't care what kind of coax you have, as long as it's cut the frequency at a half a wavelength. Now, same difference. In between this driver coming out of this driver to the 12, I'm going to say you're probably going to need a quarter wave piece of coax. Don't care what kind, don't matter, as long as a quarter wave on frequency. Okay? Now, coming out of it, normally it should be a half a wavelength. Why? Going over to your line section or your console meter up on top, dozy or not, you should have a bird at this point. You get this far up in the amplifier world, you graduate from a dozy. I'll give you that one. Now, you come over here and you say, all right, I got 12 going over, or half a wavelength going over to here, and then goes through those line sections, and then here goes off to my antenna or dummy load, okay? From that line section all the way to here, that piece of coax is incorporating those line sections. Why is that? Because it's part of that transmission line. Your transmission line will see the extra length of those line sections. So if you have 10 of them in line, you're going to have a piece of jumper on each side, probably less than a foot on each side, whatever. However, you understand my point. You have to take and incorporate all of these different things to get these measurements, to get them right, for your equipment's going to run right. I can show you demonstrations on antennas. I can show you demonstrations on dummy loads. Makes no difference. Either way, you have to go through the same thing. You want to come in and you want to see what your input reflect is going between these two amplifiers. What is going on? What is going on between the communication between this 12 and this 5? What's happening there? Well, it told me that it's pretty happy. It's like a 1.1. I got like a 1.5 watts, 2 watts reflector. So, all right, that's cool. Is that going to go up or down? I'm on a dummy load, perfect world. It's going to go up or down depending on what your reflection is on your antenna. What happens on your roof is going to happen inside your shack. And this equipment is going to show you that, and it's going to tell you that, because if you start hearing your fan speed up, slow down, do goofy things, talking at you, then something's really, really wrong with your system. A lot of times it's lack of ground at the antenna system itself. In a mobile especially. Base stations, they're not so hard to ground. You take and get a flat strap, you throw it over the side of your roof, you hook it up to a 6-foot ground rod going into the earth. A couple of them would be great. And you have yourself a nice ground. Do you agree? You agree with that? Yes? Okay. That's good. So, what you got planned this weekend, Molly? You got anything planned? No? Nothing? You got nothing? No? You don't know? Well, come here then. Come, sit. Hi. You a good girl? Yeah, here you go. Yeah. He loves her peanuts. So, Steve Mann, come here, Molly. Come here. Come on up here. Come on. Steve Mann, I want to show you something. I put this on her, I don't know, 6 or 7 times now. And her little bump, it still kind of looks bad, but the hair is actually starting to come back around this thing. And I put it on, and he said, keep on it. I forgot to put it on 2 days now, but it's really doing good. And the reason why I said that and stopped the video for that, everybody, was Steve Mann heard me say Molly had a little bump. The stinky stuff. But he sent me over this. You can get it at Tractor Supply Store, but I bought it online on Amazon, and it's here. It's like 25 bucks or so. This stuff almost looks like lithium grease. It stinks about bad, but regardless, that stuff really helps you. Yes, your little bump's gone away, isn't it, Molly? Sit. Yes. Yeah? Hi. Okay. Here you go. Here. You want that? Go get it. Go get that. It's there. Get it. There it is. All right. So, anyway, you cut it, guys. I can sit there and I build these systems, and I really try to take and give you guys the most informative information I possibly can, even if you didn't buy a unit from me. All of these rules and everything I talk about still applies to you, unless your builder tells you otherwise. But you probably shouldn't, because everything I'm telling you guys is correct. So if you follow these little laundry lists of things that you need to do, then you'll be fine with your equipment as far as how well or how good, how bad the performance is. So with that said, let's play with some knobs on this thing. Let's turn this stuff on. And I'm not going to worry so much about where my carrier level is. I'm just going to produce power. So with that said, here's wide open. And we're going to look at the peak real quick. I want to show you something with peak. So here's the unit wide open. All right. And I'm going to roll it all the way back. All right. 2900. 3500. Okay. What happens to the RMS when I do that? Wide open. I'll back it all the way down. That's your filler right there. That's your RMS filler. You're going from minimum drive power to maximum drive power right there. 300 watts a pill, or 300 watts divided into 12 pills. Here's maximum output power. Show me right at 300 watts. I back it down. Look at that. I'm doing 140 watts. There's wide open again. So that is the power of the potentiometer in its fullest and its best way that I can describe that. So potentiometers are good, and if you don't want to run the stuff wide open, you can simply roll it back. Now, if I rolled that back, it made me think about something. Here's my drive, about halfway, about 220 bird RMS. It gives me an overcome of about 1500. Let's look at the peak. All right, 3000. Now, let's just sit there and look at RMS here. So, it's showing 1600 watts out of 12 transistors right there, and I'm only driving it with about 220 watts of drive. Now, what happened if I didn't have this awesome Dustin R&R Cobra 29 in here? What if I couldn't make all that power with what that radio can do? Well, let's take it away. let's take away power out of this radio. Let's take that radio all the way down. We'll leave everything where it's at. We just saw what we're doing. Alright, this is what, it's still a halfway. See, now I'm only making 140 watts RMS. And my RMS here is now I'm only making about 1,200 watts. Boy, that's kind of terrible, isn't it? That's radio performance there. See, 1150. Now what happened to my peak? I just pulled a lot out of my radio. Wow, it dropped down too. Alright, now let's really see it drop down. Now I took my radio all the way down. I took my driver all the way down. Let's see what the driver's producing under a load. Yeah. So now I'm barely making 80 watts, maybe. I'm curious now. I don't even know if it's going to read. Let's peak. Yeah, 80 watts, like I said. Okay, so turn it back on. Another 80 watts of drive into this unit. Inputs are way down. Nothing's barely moving. And now that's 2,500 watt slug. So I'm making 1050, 1100 watts. Here's a 5 kilowatt slug. Same difference. And here's your peaker to tweaker. 2,800. And see, the peak is really high. But I just backed my radio way down. What happens if I turn this? Cody just called me. Alright, moving on. Drive level again. See, now we're wide open with a ducky radio. I'm making 250 RMS. What happened to my peak? Now I'm almost full peak. Okay? Now what happened to my RMS though? I'm at 1,500, 1,600. So, the RMS at 1,600 still is not a terrible thing. It's just the way you choose how you're going to run the system. And to show you the same difference, I took a lot of power out of my radio by dropping the voltage down. Now you don't have that option on here, but the reason why I did that is, again, not everybody's going to have that real wicked, badass Cobra 29 made by R&R. Alright? So if you don't, you might just have a radio that's producing, oh, let's just say this many watts at this voltage. Alright? So that's only producing like 25 watt slug, that's 5, 6, that's like 6 watts RMS. Alright, and this is where we were running. Somewhere in there. Okay? Now, put all that power back up in there. Now everything is going to fill up and it's going to run like a rape ape. It's wide open. Let me turn this back around so I won't slam it in the corner. And now we're back there at our 300 watts or so for drive. Now I'll take and turn that back on. Now we're back up to full output power all the way across the board. Let's see my drive level. Still right there. Input reflection hanging out right around 2.5. RMS, 50 watts a line. 1,700 there. Let's see the 5 kilowatt hanging out right under, right about 1,750. Let's see what the RMS here is on the digital. Dave, 1750, and ultimate peaker tweaker, 3550. 3550. So think about that. Add 4 more pills. You make the 4,000 and a 16 pill with drive that we put out. Now, hopefully you guys grabbed a lot out of this video. Try not to make it too terribly long. I want to sit here and talk with Molly for a second. You gonna sit? Huh? Hold on a second. I'll be back. Yeah? Molly. MooZilla. You sit? Sit. How are you? You a good girl? You want this? You sit pretty. Yes. That's what you do, huh? Crush the ducks off the trench. You sit? Give me a wave. Good girl. All right. So what you got going on this weekend? What you gonna do, huh? What you gonna think, huh? You gonna say hi? Say hi. Uh-huh. What happened? Really? You sure? You want to go out and check again? You ready? Yeah, you're ready to do that, aren't you? You sit? You sit? Okay, ready? Last one, ready? Get him. Go on, get him. Pac-Man Peanuts. Where's it at? Go find it. It's over there. Hey, Linda, it's over there. Good girl. Alright guys, there you have it. Got ourselves a beautiful power supply. Each switch is for a module. There's breakers in the back if there's a problem. This one turns on the first unit. The driver unit, I should say. Turns on the driver. As you see, I cut that off. The voltage would be gone. And that'll do it when it gets to low voltage. So I got the low voltage set, I think, at 12.1 volts, and it actually would blink like that. So I'm kind of glad that that popped up for me. Now, wondering if I turn it back on, if it's going to actually give me the setting and held it or not. I don't know if it did or didn't. I'm looking at it, might. Really upset about this, but it stayed there because I didn't cut this off. Now, if I cut this off, that little booger is going to go back to whatever. So it's a nice system, it really is. So I'll turn on one of these units here real quick. I'll go over and check it. See, I got 0.13 amps. It tells you it's off right there. Probably went back to default of 100 amp current shunt. Yes, it did. Poke it, good to go. And it'll clear itself. Turn that on, hit that. And it puts you right back over to the small power supply and goes over to the big power supply. So, there you go, guys. Hopefully you enjoyed the video. And Molly, got to catch up with a few guys, so I'm going to slide out of here. Take care. God bless. Welcome to the weekend. Talk to you all soon. I'm gone.